Hello and welcome to week 5 in research methods. And then this week we're going to be taking on two chapters, chapter 7, sampling, and chapter 8, where we're going to be looking at power and effect size. Now, first off, in sampling, one of the important things about conducting psychological research is that we're able to take our findings and say something about the larger population from which we have taken our sample. So the baseline expectation is that we want our sample in many ways to be very similar to the demographics of our population that we want to generalize our results to. To a degree, depending on where you're doing the research and how much money that you have, how much time do you have, access to people, and all that. These are continual challenges within the field of psychology. Now, because we recognize that it is challenging to find a representative sample, we still conduct research with the best sample that we can get, but then we identify possible reasons why our data may not be able to be generalized. We talk about the limitations. So we try our best with sampling to get the best representation that we can, and then we include a discussion that we acknowledge that it's imperfect and there will be limitations in terms of how much we can generalize. Now, it's important to recognize this as consumers of psychological literature, because when we hear reports about psychological findings, we often are not included on the discussion as to what the limitations are of generalizing. We have a tendency, particularly if it's good news, to generalize quite a bit, probably beyond the expectations of the original study and the people that conducted the study. So in this course, you are going to be conducting a study, and you're going to be gathering together a sample from email list, people you know, social media, and whatnot, which ultimately, if you want to just call it, is not a very good sampling method. There's a whole study on there's a whole field of study, on how do we conduct research online. That is, and the challenges with that, and why it's not perfect, and there's limitations and whatnot. That's all okay as long as we recognize the limitations. This chapter goes into not only convenience sampling, which is largely what most of you are going to be doing, it also goes into all the ways in which we very, very conscientiously try to get representative samples. For example, if my study was to look at I'm going to look at KVCC students. I'm going to define my population very small. I'm not going to say people in America or human beings in general. I'm just going to say people at KVCC. Technically, depending on the variables that I think, the factors that may impact my study, I could maybe sample very effectively with that. Like I might look at, let's say, the program that a person is in is a significant factor or may play a significant factor, then I might want to make sure that my sample has the same proportion of individuals from each program as they exist within the school. So, for example, our occupational therapy program maybe constitutes 10% of our total population at KV. The liberal studies program maybe 30% of all our students at KV. So my sample should reflect those same ratios if their program is important in my study. So those are efforts that we can make to make our sample more applicable to the populations to which we're trying to understand. So in this chapter, I'm asking you in the discussion is to actually participate in a study and reflect in the discussion what it felt like to be a subject. we shouldn't expect other people to do things that we're not willing to do ourselves. So I gave you a resource of research, real research that's going on. Find one that works with your time, works with your energies, works, maybe it's something you're interested in anyway, and participate in that study. And then reflect on what was it like. That's the discussion. In the quiz, I want you to contrast probability sampling with convenience. Now, probability is all those other ones that make an attempt to actually reflect ratios and stuff like that. All the other ones. Convenience sampling is whoever shows up. I want you to compare and contrast those. When you compare and contrast, what you have first, you have to define each one, and then you talk about how they're similar and how they're different. And in this respect, those similarities and differences should probably include pros and cons as they relate to one another. Just to get an idea about that whole set that makes an effort to kind of have generalizability, and convenience sampling, which is what we use a lot when we're initiating exploration like the way we are. So that's Chapter 7. Chapter 8 introduces you to the idea of power and effect size. Now, we often will hear like a computer is powerful, or a mathematical equation is powerful. And we use that word power to sort of generate this notion that it has a good utility to it. It is good at what it does and whatnot. And the idea of power in the concept of statistical analyses is that within the context of a particular study, we can calculate the degree to which our chosen statistical process is likely to avoid a type 2 error. Now, type 2 error is when we neglect to reject the null. There's something going on and we missed it. So, powerful statistics within the context of a study are those that are very unlikely to miss when something's going on. Probably a good way, that's kind of a neat way of explaining. Now, there are components that go into an understanding of that power, and they are the degree of significance, or you get the 0.05 or 0.01 or maybe 0.001 level of statistical significance that you are going to use. That, where's your threshold? That's there. Now, I'll tell you that 0.05 is more powerful than 0.01, and it contributes in that direction. 0.05 is easier to reach significance of your data and therefore reject your null hypothesis than a 0.01. So the tighter and more stringent, the more criteria we have so that there's less and less likelihood that this would happen by chance, that increases our power. Sample size. Now you'll see in the actual calculation, if you look at the formula for power, you'll see that sample size plays a role. Now, I'm going to use my example from KVCC. Now, if we have 1,100 students and I sample 20, even if I try to keep the proportions and whatnot, there's probably going to be very unlikely that I'm going to be able to represent, 20 to 1,100 people, kind of thing. It's a very small sample. The bigger that sample goes, all the way up to the whole population. Consider it that way. If my sample can grow to include all 1,100 people, then the bigger that sample goes, the more it looks like the whole thing. So sample size increases the notion that I am getting a representative sample of the whole population up to and including studying the whole population. So therefore, the larger the sample size, the more likely I'm going to get significant results. It increases the power. Variability within my particular measure is a factor that will lower my power. If there's lots of differences within the population, within the sample that I've got, they're very different from each other, very likely that's going to lower my power. It's going to make it more difficult for me to get significant results. The more homogeneous they are, the more everybody's alike, chances are I'm going to get, that'll increase my power. And the final factor is effect size. How much change are we looking for? How much, what are we going to consider is a significant change? And this brings into mind the term significance. Now, when we think of something that is significant, we often think of it being important. It's a significant life event, or that's a significant statement that somebody made, those kinds of things. Significance statistically is just a mathematical criteria. It doesn't distinguish that something is important. It just distinguishes that it met that 0.05 or 0.01 or beyond criteria. So what can happen is if we have a very powerful study such that we have a relatively low level of threshold for significance, we have a huge sample size, and we have very little variability, then it is more and more likely that very incremental changes will actually come out statistically significant. So let's say my study is looking at the ability for a online tool to educate people about how to engage in critical thinking, improves their ability on a critical thinking test. Now, if I sample lots and lots of people, and they're relatively the same in those criteria, and I have a 0.05 instead of 0.01, then changes on their test, very small changes that are consistent across 1,100 people, are going to be significant. Now let's then look at the other use of that word significant. Let's say the scale is a 10 is great critical thinking, and a 2 is very, very low critical thinking. And let's say after my study, after people have been exposed to this, people went from 8.3 to 8.5. There was an average of 0.2 increases in critical thinking. Putting that hat on, we would say, yeah, we got statistically significant differences, but it was, overall it was only a 0.3 effect size. So then we would ask, how much does it cost to we would look into the pragmatics. Is this a worthy thing to do? Do we want to use this video? If the video costs $12,000 a year for us to use it, and we're only getting a 0.2 increase in person's critical thinking, we may say, well, that's not significant enough for me. The effect size is not significant in terms of its importance, even though statistically it was significant. So if all those factors play out, what we have is a tool. It's a tool that is available for both Mac and Windows called G-Power. Now, G-Power is a small little application. You download it for free, and it allows you to input data in such a way that all the factors that you do know, you can put in there, and it will fill in the blanks for the one that's missing. It's sort of like you know how in algebra you solve for x. Well, this, you can have this whole formula, and you have A, B, C, and D, and you can solve for A when you know B, C, and D. You can solve for B when you go A, C, and D. All of these. So I'm having you download that piece of software, and then I give you in the quiz, I give you some data, and you're going to actually predict, well, what will my sample size need to be? So we're solving for sample size. We're not solving for power. We're gonna know the power. We think, pretty much power should be around 0.8 in the ways that we measure power using that formula. What we're going to be using the tool is to solve for a different variable, and that variable is going to be sample size. This G-power is often used for two things. First, at the beginning of your study, you might look at the existing variables and what's happened in the past, the prevalence of findings in the past, and you may calculate what you would expect in terms of your relationships to determine what is the minimal sample size, similar to what we're doing here. More often, what we do is after the study is done, we go back, we plug in all of the variables that we know, and we calculate power. So it's another way of recognizing, and be a limitation, let's say. Let's say you did your study, everything went as according to, and you ended up with a significant result and stuff, and then you go back and you measure the power of your statistics, and you find that the power, even though you got a good desired result, the power might be low. And that would be something you would indicate as a limitation, that the statistical tools that you used within the context of the study demonstrated low power. So there is a potential for a type 2 error. It would be a rationalization of making that decision. Now, based on everything that I've talked about so far, I threw in there the notion of sample size as being a very, very significant factor. As the internet has come into the world of research, and prior to that too, we have studies with literally tens of thousands of people in them, which almost guarantees we're going to have significant results. I want you to discuss that. I want you to discuss why that is a problem. All right, so that's the discussion and the quiz for Chapter 8. So this week, you have two discussions, Chapter 7 and Chapter 8, and two quizzes, Chapter 7 and Chapter 8. So enjoy this. We're still plugging away at our papers. I've graded all of the initial proposals. I'll be grading things as they come in. You are now on your own pace. Don't worry about the due dates. That's just the structure of the class. But do address the updates quickly. We want to make sure that my hope is that you are ready with these, with your proposals and your studies to begin by right around week 8. We are in week 5, the beginning of week 5, and that means a lot of work between now and week 8. Of course, if it takes longer than that, we'll go, but make that a goal that we can start making our way through the rest of these assignments, getting you ready to conduct your study by week 8. So, with that, I leave it to you. Have a great week, and I'll see you later.